So in this video I will be solving the next part of miscellaneous. So these are the problems that I will be solving from question number 25 to question number 33. This video will be the second part of the miscellaneous problem. So this is our first question. This is question number 25. This is integration pi by 2 to pi e to the power x 1 minus sine x by 1 minus cos x. This is dx. So here I will be using these formulas, that is half angle formula. So this is 1 minus sine x. So this is, you see, sine x formula. This is 2 sine x formula, 2 sine x by 2 cos x by 2. This formula comes from sine 2x formula. We know that sine 2x is equals to 2 sine x cos x. Now since for 2x the angle is x here, in the right hand side the angle becomes x, so for x it will become x by 2 x by 2. And 1 minus, you see, again cos 2x, it is 1 minus 2 sine square x. So cos 2x, this 1 if it comes to left hand side, cos 2x minus 1 is equals to minus 2 sine square x. So it will be 1 minus cos 2x. If I multiply both sides by minus, it will become 1 minus cos 2x, and this will be 2 sine square x. So again here you see this is 1 minus cos x. For cos 2x it is sine square x. So therefore for 1 minus cos x it will be 2 sine square x by 2. So this will be pi by 2 to pi e to the power x. This top it will be 1 minus, this is 2 sine x by 2 cos x by 2 by 1 minus cos x, it will be 2 sine square x by 2. This is dx. So next is equals to pi by 2 to pi, what I got here, e to the power x 1 minus 2 sine x by 2 cos x by 2 by, this is 2 sine square x by 2. This is dx. This is dx. So this is pi by 2 to pi e to the power x. Now if I split the denominator, 2 sine square x by 2 minus 2 sine x by 2 cos x by 2 by 2 sine square x by 2, this is dx. So now this is equals to pi by 2 to pi e to the power x. This it will be cosec square x by 2, yes, 1 by sine square x by 2, it will be cosec square x by 2 minus, here you see this 2 and 2 cancels out, 1 sine x by 2 and 1 sine x by 2, it will cancel out. So ultimately I will get here cot x by 2, yes, cos x by 2 by sine x by 2, it will be cot x by 2, and this is our dx. Now if I split the integration pi e to the power x cosec square x by 2 minus e to the power x cot x by 2, this is our dx. So now split the integration pi by 2 to pi e to the power x cosec square x by 2, this is dx, minus pi by 2 to pi e to the power x cot x by 2, this is dx. So now this becomes 1 by 2 pi by 2 to pi e to the power x cosec square x by 2 dx minus pi by 2 to pi e to the power x cot x by 2 dx. Now here what I will do, I will keep this part same. I will do the integration here. This integration will be done by integration by parts. Let me show it separately. Remember, I will keep this part same, this left part. I will keep this part same. I will do the integration of only this right side. This part I will do the integration of. So let's do the integration separately. This is pi by 2 to pi e to the power x cot x by 2 dx. ILATE, this is our trigonometric function, will be the first function. So this it becomes cot x by 2 pi by 2 to pi e to the power x dx minus integration pi by 2 to pi differentiation of cot x by 2 by dx by 2 dx by 2 by dx. Then again integration e to the power x dx, this is dx. So this will be our e to the power x cot x by 2. This I will have to give the limit pi by 2 to pi, and this is minus integration pi by 2 to pi differentiation of cot x or in this sense cot x by 2, it will be minus cosec square x by 2, and this will be into 1 by 2, and this will be e to the power x here whole dx. Okay, this is differentiation of dx by 2. Yes, by dx, this will be 1 by 2, this is dx by dx, so ultimately it will be 1 by 2. Yes, so this will ultimately it will be 1 by 2, and integration of e to the power x dx, it will be e to the power x. So here this whole thing, you see, it becomes, here this minus is there, so ultimately this thing becomes e to the power x cot x by 2, this is pi by 2 to pi, this will be plus. Yes, this is minus there, minus, it is minus 1 constant, it will come out of the integration, so minus into minus, it will be plus integration pi by 2 to pi, and this 1 by 2 is also constant, so it will also come out 1 by 2, and this whole thing it will become e to the power x cosec square x by 2 dx. So this is what I got. Keep it as it is. Yes, this is what I got here, so we will keep this as it is. Now you see, I have done the integration of this part. Yes, I have done the integration of this part. Now let me write this whole part. So I have done only the integration of this. So this is what I have got. This was our integration. Yes, this was our integration. I have got this one. So let me write it down. Integration of pi by 2 to pi. Yes, integration of pi by 2 to pi. Then it is e to the power x 1 minus sin x by 1 minus cos x. E to the power x 1 minus sin x by 1 minus cos x. This is dx. This is integration. What I have got? Integration I have got this one. Yes, 1 by 2, this one 1 by 2 integration, 1 by 2 integration pi by 2 to pi e to the power x cosec square x by 2 dx, e to the power x cosec square x by 2 dx, then minus pi by 2 to pi, then minus, this is pi by 2 to pi, pi by 2 to pi e to the power x cot x by 2 dx, e to the power x cot x by 2, this is dx. Yes, this is what I got. So this is equals to is equals to 1 by 2 integration pi by 2 to pi e to the power x cosec square x by 2, this is dx, minus this part integration I have done and I got this answer. So let's give a big bracket here, then this is e to the power x cot x by 2 pi by 2 to pi plus 1 by 2, this is integration pi by 2 to pi, and then e to the power x cosec square x by 2, yes, cosec square x by 2, this is dx, square bracket close. So here is equals to 1 by 2 pi by 2 to pi e to the power x cosec square x by 2 dx, this minus, open the bracket, minus this will be e to the power x cot x by 2 pi by 2 to pi, minus into plus, it will be minus 1 by 2 pi by 2 to pi e to the power x cosec square x by 2 dx. Okay, so now here you see this whole part and this whole part cancels out. Okay, these two parts it cancels out, so ultimately I get here is equals to minus e to the power x cot x by 2, this is pi by 2 to pi, yes, this is pi by 2 to pi. Okay, so now next is equals to, it will be minus this is our e to the power pi cot pi by 2 minus e to the power pi by 2 cot, this is pi by 2 by 2 pi by 2 by 2. So this is equals to minus e to the power pi cot pi by 2 minus e to the power pi by 2 cot pi by 4, yes, cot pi by 4. So here you see cot pi by 2, yes, cot pi by 2 it is 0, cot pi by 2 it is 0. Okay, cot pi by 2 it is 0 and cot pi by 4 it is 1, yes. So therefore minus this whole part it will become 0 minus cot pi by 4 is 1, so it will be e to the power pi by 2. So this ultimately I will get minus bracket start minus e to the power pi by 2. Yes, so ultimately what will be the answer is equals to e to the power pi by 2. So this will be the answer. So this is the next question. This is integration 0 to pi by 4. This is sin x cos x by cos x to the power 4 plus sin x to the power 4 dx. So here 0 to pi by 4, what I will do, I will divide both the numerator and the denominator by cos x to the power 4. So this will be 1 plus sin x to the power 4 by cos x to the power 4, this is dx. So here you see cos x and 1 cos x, it will cancel out. So this is ultimately I will get 0 to pi by 4, this is sin x by cos cube x by 1 plus this will be 10x to the power 4, this is dx. This will be is equals to 0 to pi by 4, this is, you see, I can write sin x by cos x into 1 by cos square x, this is cos cube x there, by 1 plus 10 to the power 10x to the power 4, this is dx. So this is equals to 0 to pi by 4. This will be 10x into, this will be 6, this will be 6 square x, and this is 1 plus 10x to the power 4. This is dx. So here I will take, let t is equals to 10 square x. This one I can write it as 0 to pi by 4. This is 10x 6 square x by 1 plus 10x to the power 2 to the whole power 2 dx. I will take, let t is equals to 10 square x. So if I differentiate it, this is 10 square x by d 10x into 10x by dx. So this will be 2 10x, differentiation of 10x, this is 6 square x. So dt by dx is equals to, I got 2 10x 6 square x. So this one, it will become dt by 2 is equals to 10x 6 square x dx. You see, I got the numerator. Now I will also have to change the limit here. This is 10 square x, lower limit is 0, so therefore t is equals to 10 square 0. This will be ultimately 0, and pi by 4, t is equals to 10 square pi by 4. 10 pi by 4, it will be 1. Yes, 10 pi by 4, it will be 1. So this will be ultimately 1. Yes, 1 square, it will be ultimately 1. This whole thing, it will become 0 to 1, 0 to 1, dt by 2 by, dt by 2 by, this is 1 plus t square. Yes, 1 plus t square. So this is equals to 1 by 2, 0 to 1, dt by 1 plus t square. Now this is formula, dt by 1 plus t square. This will be 1 by 2. This is our 10 inverse t, 10 inverse t, and the limit 0 to 1. So this is ultimately is equals to 1 by 2, 10 inverse 1 minus 10 inverse 0. Yes, 10 inverse 1 minus 10 inverse 0. 1 by 2, this will be pi by 4 minus 0. So this will be 1 by 2 into pi by 4. This will be pi by 8. So this is the answer. So this is our next question. 0 to pi by 2. This is cos square x by cos square x plus 4 sine square x. This is dx. So here 0 to pi by 2, cos square x by, here if I take cos square x common, I will get 1 plus 4 sine square x by cos square x. This is our dx. So this cancels out. 0 to pi by 2, this will be 1 by 1 plus 4 10 square x. This is dx. Here if I take, let t is equals to 10x, so dt by dx is equals to 6 square x. dt is equals to 6 square x dx. Now here you see, dt is equals to, we have a formula, 6 square x minus 10 square x is equals to 1. So 6 square x is equals to 1 plus 10 square x. So in place of sec square x I can write 1 plus tan square x dx. This is what I got. So dt is equals to 1 plus tan square x dx. So dt by 1 plus tan square x will be is equals to dx. Yes, dt by 1 plus tan square x is equals to dx. Now here you see tan x value I have taken as t, so 1 plus tan square x, so this one I can write it as you see dt by 1 plus tan square x is equals to dx. So this is I can write it as dt by 1 plus t square is equals to dx, because tan x value I have taken it as t. So therefore tan square x I can say this is 1 plus t square is equals to dx. So now I will also have to change the limit. Lower limit is 0, upper limit pi by 2. So t is equals to tan x, lower limit is 0, x value if I give 0, tan 0, this will be ultimately 0. And then upper it is pi by 2. So again here you see t is equals to tan x, so t is equals to tan pi by 2. So tan pi by 2, this is infinity. So now I will have to change the limits, that is 0 to infinity. Yes, 0 to infinity. Dx value how much I got? Dx value I got this dt by 1 plus t square. So in place of dx I will have to write dt by 1 plus t square, and this it will become, since tan x value is t, so this it will become 1 plus 4 t square. Yes, so this is 0 to infinity 1 by 1 plus 4 t square, and this is into, in place of, this is already, you know, this is multiply, so no need to write the, no need to give the sign here. So dx value it is dt by 1 plus t square. Yes, this dx value, this became 1 by 1 plus 4t square, and into dx there, dx value it is dt by 1 plus t square. So this is dx, in place of dx I will write dt by 1 plus t square, 1 plus t square. So this, if I write it nicely, 0 to infinity I will get dt by 1 plus 4t square into 1 plus t square. So this is what I got. Now I will use partial fraction. Yes, I will use partial fraction. So this is, I can write 1 by 1 plus 4t square, and this is 1 plus t square. This one I can write it as a by 1, this will be a x plus b by 1 plus 4t square plus cx plus d by 1 plus t square. So here if I take LCM, 1 plus 4t square, 1 plus t square, this will be ax plus b, 1 plus t square plus cx plus d, this will be 1 plus 4t square. So now if I multiply it, ax plus axt square plus b plus bt square plus cx plus here I made a small mistake here. The mistake is that this is x I cannot take, because the variable is t, the variable that I am dealing with, it is t, so therefore I will take at, this is ct, this will be at, and this will be ct. Now I will multiply it, so this will be at plus at cube. Yes, at into 180, 80 into 80 square, 80 cube, plus b plus bt square plus ct plus 4ct cube, and this will be plus d into 4 t square. This will be 4dt square. This is our ct plus 4 ct square. Okay, let me do it properly. So this is equals to, this one multiply it, I will get at plus at cube. Yes, at into at square, at cube plus b plus bt square plus ct plus 4ct cube plus d plus 4dt square. This is by 1 plus 4t square 1 plus t square. Okay, so this is 1 by 1 plus 4t square 1 plus t square, 1 by 1 plus 4t square 1 plus t square. So this ultimately I will get, this one denominator it will cancel out. Ultimately I will get 1 is equals to at plus at cube plus b plus bt square plus ct plus 4ct cube plus d plus 4dt square. So 1 is equals to this is at cube. Yes, this is at cube. Okay, so now this is t cube like terms. Let me write it together. At cube plus 4 ct cube plus bt square plus 4dt square plus at plus ct plus b plus d. So this is 1 is equals to a plus 4c t cube plus b plus 4d t square plus a plus c t plus b plus d. Now I will equate it, left hand side right hand side I will equate it. For t cube there is no like term here, so it will be, I will consider it as 0. So therefore a plus 4c is equals to 0. Again for t square there is no like term here, I will consider it as 0. For t there is no like term, a plus c is equals to 0. For this constant b plus d, it has a like term, this is 1. So therefore b plus d will be equals to 1. Now this is equation 1, this is equation 2, this is equation 3, and this is equation 4. Let's take equation 1 and 2, let's write them together. So this is a plus 4c is equals to 0 and a plus c is equals to 0. If I subtract these two equations, a and a cancels out, this will be 3c is equals to 0, c will be equals to 0. C value, if I put it in equation 3, I will get a value also is equals to 0. I will get c value and a value, I got 0. Now let's take equation 2 and equation 4. So b plus d is equals to b plus 4d. b plus 4d is equals to 0 and b plus d is equals to 1. If I subtract these two equations, b cancels out, 3d is equals to minus 1, d is equals to minus 1 by 3. If I put it in this equation, b minus 1 by 3 is equals to 1, b is equals to 1 plus 1 by 3, b is equals to, this will be 4 by 3. So a value I got 0, b value I got 4 by 3, c value 0, d value I got minus 1 by 3. Now these values put it in here, I will put it in here. So this is what I got here, integration 0 to infinity 1 by 1 plus 4t square, 1 by 1 plus 4t square, and 1 plus t square. This is dt is equals to, yes, this is dt, this is 1 by, I got this, is equals to, this is integration at plus b by 1 plus 4t square, this is dt, this is again 0 to infinity plus 0 to infinity, this was our ct plus d by 1 plus t square, ct plus d by 1 plus t square, this is dt. So 0 to infinity, a value is 0, yes, a value is 0, b value it is 4 by 3, so this I will put it 4 by 3 by 1 plus 4t square dt plus 0 to infinity, c value is 0, yes, c value is 0, d value is minus 1 by 3, so minus 1 by 3, 1 plus t square dt. So this will be 4 by 3, 0 to infinity, 1 by 1 plus 4t square dt. This will be minus 1 by 3, 0 to infinity, 1 by 1 plus t square dt. So now here I will use formula. This is coefficient of t square is 4. This 4 I will have to take common. So this will be is equals to 4 by 3 into 1 by 4. This 4 I have taken common. So ultimately this becomes 0 to infinity. This is 1 by 4 plus t square dt. This is minus 1 by 3, 0 to infinity, and this is 1 by 1 plus t square dt. So this 4 cancels out, 1 by 3, 0 to infinity, 1 by, this will be, I will get 1 by 2 the whole square plus t square dt, minus 1 by 3, 0 to infinity, 1 by 1 plus t square dt. So this is our formula 1 by 3. So the formula that will be used here, it is this formula, that is integration dx by x square plus a square. The formula is 1 by a tan inverse x by a plus c. So this is the formula. So here this will be 1 by a is here 1 by 2, so 1 by 1 by 2 tan inverse t by 1 by 2, yes, tan inverse t by 1 by 2 x by a, so t by 1 by 2, so this is minus 1 by 3, again here tan inverse t by 1, that is ultimately it will be t. So here I will have to give this is 0 to infinity, and here this is 0 to infinity. So this is ultimately, this is 1 by 1 by 2, this is constant, it will come out. So this will be ultimately, this is I will get 1 by 3 into 2, yes, this is tan inverse 2t, t by 1 by 2, this will be 2t, this is 0 to infinity, and then minus 1 by 3, this is tan inverse t, this is our 0 to infinity. So this will be 2 by 3, this is tan inverse, this is 2 into infinity, ultimately it will be infinity, and this is minus tan inverse 0 minus 1 by 3, this is tan inverse infinity minus tan inverse 0. So tan inverse infinity, tan inverse 0, it will be 0, tan inverse infinity, it will be pi by 2. So this is equals to 2 by 3, this is pi by 2 minus 1 by 3, this is pi by 2. So this ultimately I will get, it is 2 by 3 into pi by 2. Yes, 2 by 3 into pi by 2 minus 1 by 3 into pi by 2. Okay, so this is here 2 and 2 cut, so pi by 3 by pi by 6. If I take LCM, it will be 6, 2 pi minus pi, so ultimately pi by 6. This will be the answer. So this is the next integration, question number 28. So integration pi by 6 to pi by 3, this is pi by 6 to pi by 3, sin x plus cos x by root over sin 2x dx. Now here you see this denominator sin 2x. Sin 2x formula is 2 sin x cos x. Here what I can do, you see this is 2 sin x cos x. I can write 2 sin x cos x plus 1 minus 1. So this whole thing I can write it as 1 minus 1 plus 2 sin x cos x. 1 from here, from these two terms I will take minus common, so this will be 1 minus 2 sin x cos x. Okay, now 1 minus, this is 1 I can write it as cos square x plus sin square x minus 2 sin x cos x. Okay, so this is 1 minus, this is our formula, cos x minus sin x, yes, cos x minus sin x the whole square. Okay, so here as you can see, from sin 2x, which is 2 sin x cos x, from here I got this. Yes, I modified this a little bit, and from here I got this. So now here you see, this is our integration. This is our integration. So pi by 6 to pi by 3, this is sin x plus cos x by root over, in place of sin 2x I can write 1 minus cos x minus sin x the whole square. This is dx. Okay, sin 2x I can write 1 minus cos x minus sin x the whole square. This is dx. Let me write this one more time. Pi by 6 to pi by 3, this is our sin x plus cos x by root over 1 minus cos x minus sin x the whole square. This is dx. Now I will take, let t is equals to cos x minus sin x. T is equals to cos x minus sin x. So dt by dx is equals to differentiation of cos x, this is minus sin x, and this is minus cos x. So dt by dx is equals to, if I take minus common, I will get sin x plus cos x. Yes, I will get sin x plus cos x. So this is dt by minus 1 is equals to sin x plus cos x. This is dx. You see, I got the numerator. Yes, I took this as t and I got the numerator. So therefore pi by 6 to pi by 3, sorry, this is a misheard. Since I have you see changed the variable, since from x I have taken it to t, okay, t is equal to cos x minus sin x, so now I will have to change the limit. Yes, I will have to change the limit here. So to change the limit, lower limit, here it is pi by 6. So t value, t is what? T is cos x minus sin x. So lower limit is pi by 6. So cos pi by 6 minus sin pi by 6. T cos pi by 6. So this is cos pi by 6. Cos pi by 6, it will be root 3 by 2 minus sin pi by 6. This is 1 by 2. So t is equals to root 3 minus 1. Okay, so this will be our lower limit. Yes, this will be our lower limit, and upper limit, this is our lower limit, this is upper limit, this is our pi by 3. Yes, pi by 3. So cos pi by 3 minus sin pi by 3. Yes, sin pi by 3. So t is equals to cos pi by 3. Cos pi by 3, this is 1 by 2 minus, this is root 3 by 2. So this is t is equals to 2, 1 minus root 3. Okay, this is 1 minus root 3. This is upper limit. So therefore integration, lower limit is root 3 minus 1 by 2, and upper limit is 1 minus root 3 by 2. Okay, this is upper limit. So this is, in place of sin x plus cos x, this will be dt by minus 1, and this will be root over 1 minus, this is t square. Okay, so therefore here you see this will be dt by minus 1 by root over 1 minus this will be t square. Okay, this is what I got here. So this is equals to root 3 minus 1 by 2, 1 minus root 3 by 2. This will be our here, this is minus 1, it is constant, it will be outside. So this is minus dt by root over 1 minus t square. Okay, this is what I will get. Now you see, this is formula. Okay, this is integration, this is formula. The formula is, this is formula here. The formula will be integration dx by root over a square minus x square. This is equals to sine inverse x by a plus c. So this is the formula that I will use here. Okay, so this will be equals to minus this will be our sine inverse t. Yes, this will be sine inverse t. A is 1 here, so t by 1 t by 1, ultimately it will be sine inverse t, and this is limit root 3 minus 1 by 2, 1 minus root 3 by 2. Yes, 1 minus root 3 by 2. So now here is equals to minus, this is bracket, sine inverse 1 minus root 3 by 2. Yes, 1 minus root 3 by 2 minus sine inverse root 3 minus 1 by 2. Okay, so here you see, here what I can do is equals to minus, you see this is sine inverse 1 minus root 3 by 2. Yes, 1 minus root 3 by 2 minus sine, this is sine inverse root 3 minus 1 by 2. Yes, this is what I have got here. Give a bracket, this is bracket. Okay, here give brackets here. Okay, done. So now what I can do, here you see sine inverse, here I will take minus 1 common or minus common. I will get root 3 minus 1 by 2. Okay, minus sine inverse root 3 minus 1 by 2. This is bracket closed. So now minus, this is, you see, sine inverse minus x, it will be minus sine x. Okay, sine inverse minus x, it is minus sine x. So here it will be minus sine inverse root 3 minus 1 by 2. Okay, root 3 minus 1 by 2 minus sine inverse, this is again root 3 minus 1 by 2. This is bracket closed. Okay, so here you see minus minus, yes, this will be, these two are like terms now, they are carrying the same sign, so I will have to add them. So this is ultimately I will get minus bracket start minus 2, yes, minus 2 sine inverse root 3 minus 1 by 2. Yes, this is what I got, sine inverse root 3 minus 1 by 2. So this minus, if I multiply it, I will get 2 sine inverse root 3 minus 1 by 2. This will be the answer. So this is the next integration, integration 0 to 1 dx by root over 1 plus x minus root x. So here what I will do is equals to 0 to 1, both numerator and denominator I will multiply it by, this is root over 1 plus x plus root x by root over 1 plus x minus root x, root over 1 plus x plus root x. That is, I will rationalize it. Yes, I will rationalize it. So this is equals to 0 to 1, numerator will be root over 1 plus x plus root x by, this will be root 1 plus x the whole square minus root x the whole square dx. So this will be 0 to 1 root over 1 plus x plus root x by, this will be 1 plus x minus x dx. This cancels out, 0 to 1 root over 1 plus x plus root x, this is dx. So this will be is equals to 0 to 1 root over 1 plus x dx, 0 to 1 root x dx. So this will be 1 plus x, if you do the integration, 1 by 2 plus 1 by 1 by 2 plus 1. This is 0 to 1 plus x, 1 by 2 plus 1 by 1 by 2 plus 1. This is 0 to 1. So this is ultimately, this will be 3 by 2, which is 2 by 3. This is 1 plus x to the whole power 3 by 2, 0 to 1, plus this will be again 2 by 3 to the whole power, this is x 3 by 2, 0 to 1. Okay, so here if I take 2 by 3 common, so this is 2 by 3 bracket, what I will get here is this is our 1 plus x 3 by 2, yes, to the power, give a good nice bracket, big square bracket here, plus this will be again x to the power 3 by 2 to the whole power 0 to 1. This is bracket close. So this is 2 by 3. This will be 1 plus 1 to the whole power 3 by 2 minus 1 plus 0 to the whole power 3 by 2 plus 1 to the power 3 by 2 minus 0. This is square bracket. So this is 2 by 3. This will be 2 to the power 3 by 2 minus 1 to the power 3 by 2 plus this will be 1 to the power 1 to the power 3 by 2. Yes, 1 to the power 3 by 2. This is bracket close. So ultimately this whole thing, it will be 2 by 3. This is 2 to the power 3 by 2 minus 1 and this is plus 1. So this and this cancels out. 2 by 3 into 2 to the power 3 by 2. Again you see this is same base, power will be added. So 2 1 plus 3 by 2 by 3. So this is equals to, I will get 2 to the power 5 by 2 by 3. Yes, this is I got. Now you see 2 to the power 5 by 2. This is here, you see 2 to the power 5 by 2. So this one I can write it as 2 to the power 1 by 2 to the whole power 5. So this is root 2 to the whole power 5. So this is root 2 into root 2 into root 2 into root 2 into root 2. Root 2 into root 2, this will be 2. Root 2 into root 2, this will be 2. So 2 into 2, this will be 4. So ultimately I got here 4 root 2. Yes, I got 4 root 2. So therefore this one I can write it as 4 root 2 by 3. So this will be the answer. Okay, rationalize it and then split the integration. This is integration root over 1 plus x means 1 plus x to the whole power 1 by 2. If I integrate it, I will get this. Put the values and you will get the answer. So this is the integration 0 to pi by 4. This is sin x plus cos x by 9 plus 16 sin 2x. This is dx. So here what I will do, I will do let t is equals to sin x minus cos x. Okay, remember this dt by dx, this I will get cos x, this I will get minus sin x. So this is our dt by dx is equals to cos x plus sin x. So this is dt is equals to, this is what I got, cos x plus sin x, and this is our dx. So if I take t is equals to sin x minus cos x, then dt is equals to cos x plus sin x dx I will get. Next you see t is equals to, if I square it, t is equals to sin x minus cos x. If I square it, t square is equals to sin x minus cos x the whole square. So this is t square is equals to sin square x plus cos square x minus 2 sin x cos x. So t square is equals to 1 minus 2 sin x cos x. So t square is equals to 1 minus, this is, it will become sin 2x. So this is t square is equals to, I got 1 minus sin 2x. Yes, t square is equals to 1 minus. So t square minus 1 is equals to minus sin 2x. So 1 minus t square is equals to sin 2x. Yes, sin 2x is equals to what I got here. Sin 2x is equals to, I got 1 minus t square. So this value I will put it in here. Yes, this value I will put it in here. So this is 0 to pi by 4 sin x plus cos x dx. This will be dt. Yes, this will be dt by, this is 9 plus 16 sin 2x. Sin 2x value what I have got? I got this 1 minus t square. Yes, sin 2x value I got 1 minus t square. So this is, I put it in here. Okay, so one thing here, you see, as soon as I have taken this t is equals to sin x minus cos x, as soon as I have changed the variable, I will also have to change the limit. Remember here, this limit I cannot write here, I will also have to change the limit. So now t is equals to, I have taken t is equals to sin x minus cos x. T is equals to, I have taken sin x minus cos x. Lower limit is 0. So t is equals to sin 0 minus cos 0. T is equals to sin 0 means 0 cos 0. This is t is equals to minus 1. Next again t is equals to sin x minus cos x. T is equals to upper limit is pi by 4. So sin pi by 4 minus cos pi by 4. Okay, so t is equals to, so this is sin pi by 4, 1 by root 2 minus 1 by root 2. So this will be ultimately, I will get 0. So lower limit I got minus 1, upper limit I got 0. So this I will put it in here. So this is 0 to lower limit I got minus 1. Lower limit I got minus 1 to 0. So this is what I will get here, is equals to minus 1 to 0 dt by 9 plus 16, 1 minus t square, 1 minus t square. So this is equals to minus 1 to 0 dt by 9 plus 16 minus 16 t square. So this is, I will get minus 1 to 0 dt by 25 minus 16 t square. 25 minus 16 t square, minus 1 to 0. So this is dt by, this will be 5 square minus 4t the whole square. Let's do one thing here. You see, this is 25 minus 16. This comes in the form of formula. This coefficient of t square, this 16 I will have to remove. So what I will do, I will take 16 common. So 25 by 16 minus t square. So this will be ultimately 1 by 16 minus 1 to 0 dt by 5 by 4 the whole square minus t square. Yes, so this is, I got this one again. The formula, it is integration dx by a square minus x square. A square minus a is equals to 1 by twice a log a plus x by a minus x plus c. This is the formula. Okay, this is the formula. So this is equals to, I will get 1 by 16, 1 by twice a is this 1 by 2, 5 by 4, 1 by twice a log modulus a plus x 5 by 4 plus t by 5 by 4 minus t. This one I will give minus 1 to 0. Okay, this is what I got. Again, let me write it properly here, is equals to what I got, 1 by 16, 1 by 16. This is your 1 by 2 into 5 by 4, 2 into 5 by 4 log this is 5 by 4 plus t by 5 by 4 minus t. This is your minus 1 to 0. So this is equals to 1 by 16. This is 2 2s are, so 1 by 5 by 2 log, this is our 4 5 plus 4t by this is 4 5 minus 4t, this is log this one over minus 1 to 0. So this one ultimately this is 1 by 16 into 2 by 5 log this one I will get 5 plus 4t by 5 minus 4t. Okay, 5 minus 4t, this is constant so it will be outside, this is our limit minus 1 to 0. Okay, this is our limit minus 1 to 0. Now here if I do this one, you see this is 2 8 just 16, 2 8 just 16, so this is I will get 1 by 40 log 1 by 40 log, this is upper limit is 0, so this is 5 plus 0. Okay, 5 plus 4 into 0, this will be 0 by 5 minus 0, then lower limit minus log this will be our minus log 5 minus 4 into minus 1 by 5, sorry this is plus minus 4 into minus 1 finished, and then this is bracket closed, this bracket I have to close it. So this is 1 by 40, this is our log 5 by 5, yes this is our log 5 by 5. So this is 5 by 5 minus log this is our 5 minus 4, 5 plus 4, so this is 1 by 40, this will be log 1 minus log this will be 1 by 9, yes this will be log 1 by 9. These are all positive, so here no need to give modulus here. So log 1 means I know it is 0, so is equals to I will get 1 by 40, yes 1 by 40, this will be minus log 1 by 9. Now this is log property there, this is minus, it will become positive if I do this log 9. Okay, so again you see 1 by 40 log 9 means I can write 3 square, so again this is 1 by 40 3 square, this will it will become into 2 log 3, yes 2 log 3. So this is ultimately is equals to I got 2 by 40 log 3, so this is it will cancel out, so I will get 1 by 20 log 3, so this will be the answer. Next question number 31, this is integration 0 to pi by 2 sine 2x tan inverse sine x dx. So here 0 to pi by 2 sine 2x I can write 2 sine x cos x tan inverse sine x, this is dx. Here if I take let t is equals to sine x, dt by dx is equals to cos x, dt is equals to cos x dx. So this 2 is constant, it will be outside 2 0 to pi by 2 sine x cos x tan inverse sine x dx. So this whole thing I can write it in this way, is equals to 2 0 to pi by 2 this is sine x tan inverse sine x cos x dx, yes cos x dx. So this is equals to 2 0 to pi by 2, so t is equals to, I have taken sine x. So if I put it, this limit I will have to change it. So t is sine x, so this is t, tan inverse t, and cos x dx is dt. So this is dt. I will also have to change the limit here. T is equals to, I have taken as sine x, so t is equals to sine 0. Yes, t is equals to sine 0. This will be 0. T is equals to sine pi by 2. This will be 1. So therefore 0 to 1. Now here I will have to do integration by parts. So this is, you see, ILATE, inverse function. Inverse function, it will be first function. This is 2. Let's give a bracket here. This is tan inverse t, 0 to 1 t dt minus integration tan inverse t by dt, integration 0 to 1 t dt. This limit here, no need, this is inside the integration. This is dt. Okay, and this is bracket our close. Yes, this is bracket our close. Okay, so is equals to, again 2 is equals to 2. This is bracket tan inverse t. This is t square by 2. This will be t square by 2. But remember, this, in this whole I will have to give the limit 0 to 1. This whole minus here integration 0 to 1, 0 to 1 differentiation of this, it will be 1 by 1 plus t square. Yes, differentiation of this will be the differentiation of tan inverse t. It will be 1 by 1 plus t square, and this, it will be t square by 2, and this is our dt. Okay, so this is equals to 2 bracket start. This I will get t square tan inverse t by 2 by 2. This will be our 0 to 1. Okay, there is a 2 outside. 0 to 1. This will be again minus, this is, I got 1 by 2, 0 to 1 t square by 1 plus t square dt. Okay, so now here you see, here I will get is equals to 2 bracket start, put the limits here. This will be tan inverse 1 by 2 minus this is t square. If I put 0 here, this whole thing, it will be 0 only, so this will be 0. Okay, this will be 0. This is minus 1 by 2, integration of this, integration 0 to 1. This, what I will do, I will do it in this way, t square plus 1 minus 1 by, this is t square plus 1. 1 plus t square means t square plus 1. This is dt. So this is equals to 2 tan inverse 1. This will be pi by 4 by 2 minus 1 by 2. This will be 0 to 1. This will be t square plus 1 by t square plus 1 dt. Give a bracket here, dt minus 0 to 1. This is 1 by t square plus 1. This is dt. Bracket close, and this is mean square bracket close. So this is twice this, it will be pi by 8 minus 1 by 2. So this is, I will 0 to 1 t square it will cancel out. Ultimately I will get dt here minus this one minus this is, this one our formula. The formula, it will be 1 by a tan inverse x by a. A is 1 here, so this will be ultimately tan inverse t this is our tan inverse t, and this will be from 0 to 1. Okay, bracket close. This is bracket close here. So this one again is equals to 2 bracket start pi by 8 minus 1 by 2. Integration of this will be t. Yes, this will be t bracket 0 to 1. This is minus tan inverse 1 minus tan inverse 0. Yes, tan inverse 0 square bracket. This is closed. 2, this is pi by 8 minus 1 by 2. This will be 1. Yes, this will be 1 minus tan inverse. This is pi by 4 minus 0. Yes, pi by 4 minus 0. This is 2 pi by 8 minus 1 by 2. This is 1 minus pi by 4. Yes, 1 minus pi by 4. So now here this is equals to 2 bracket start. This is pi by 8 minus this one I will multiply here, minus 1 by 2 I will multiply here. So this is I will get minus 1 by 2. Yes, minus 1 by 2 plus pi by 8. Yes, pi by 8 minus 1 by 2 into minus pi by 4, it will be plus pi by 8. So this is 2 pi by 8 plus pi by 8, it will be 2 pi by 8 minus 1 by 2. So this will be 2 pi by 4 minus 1 by 2. Multiply this 2 here. Yes, multiply this 2. So I will get 2 pi by 4 minus 2 by 2. So ultimately this will be pi by 2 minus 1. So this will be the answer. So this is question number 32. Integration 0 to pi x tan x by sec x plus tan x dx. This is I is equals to. So here first of all what I will do, I will divide both the numerator and the denominator, or okay, sorry, let's do, I will not divide, let's do this. Tan x, you see tan x I can write it as sin x by cos x, by sec x means 1 by cos x, tan x means sin x by cos x. This is dx 0 to pi. So this is equals to, this is I is equals to 0 to pi x sin x by cos x by, this is cos x 1 plus sin x, this is dx. So here you can see that this cos x and this cos x, it will cancel out. Yes, cos x and cos x, it will cancel out. So ultimately I will get, here you see, ultimately I will get I is equals to 0 to pi x sin x by 1 plus sin x dx. This is what I got. So here what I will do is that I will take this as equation 1. Let me do it in next page. This is what I got. What I got is I is equals to 0 to pi. Yes, 0 to pi x sin x by 1 plus sin x. 1 plus sin x. This is dx. This is equation 1. Okay, this is equation 1. Okay, this one I will take it as equation 1. Now what I will do, I will use property here. Using property, I will use this property here. 0 to a fx dx is equals to 0 to a fa minus x dx. I will use this property. So I will get I is equals to 0 to pi. This is pi minus x sin pi minus x by 1 plus sin pi minus x. This is dx. Okay. So sine pi minus x, you see this one I will get I is equals to 0 to pi, yes, pi minus x, this is sine pi minus x, it will be sine x by, and this is 1 plus sine pi minus x, 1 plus this will be sine x, this is dx. So I will take this as equation 2. Now I will do 1 plus 2. So left hand side it will be twice a integration 0 to pi. Equation 1, this is our equation 1. 0 to pi, this is x sine x by, this is 1 plus sine x dx plus 0 to pi, this is pi minus x sine x by 1 plus sine x, this is dx. So next, this is twice I is equals to 0 to pi. This one I can write x sine x 1 plus sine x plus pi minus x, this is sine x by 1 plus sine x, this is I will write this is dx. So this is twice I is equals to 0 to pi. This is our 1 plus sine x, this is x sine x plus pi by x sine x, this is our dx. So this one twice I is equals to 0 to pi x sine x plus pi sine x minus x sine x by 1 plus sine x dx. This and this cancels out. So twice I is equals to 0 to pi sine x by 1 plus sine x, this is our dx. So next here I will get twice I is equals to, here you see this pi is constant, so pi 0 to pi, this is sine x by 1 plus sine x, this is dx. So twice I is equals to pi here what I will do, this is sine x plus 1 minus 1, I will do 1 plus sine x, this is dx. Again split the denominator, twice I is equals to pi 0 to pi, this is sine x plus 1 by 1 plus sine x minus 1 by 1 plus sine x, this is our dx. So this is equals to twice I is equals to pi 0 to pi. So this is, you see, I can write it as in this way, 1 plus sine x by 1 plus sine x, yes, 1 plus sine x, this is sine x plus 1 or 1 plus sine x, this is same, minus 1 by 1 plus sine x, this is our dx. So this is twice I is equals to pi, this will be 1 minus 1 by 1 plus sine x, this is our dx. Again split the integration, twice I is equals to pi bracket 0 to pi, this is 1 dx minus 0 to pi 1 by 1 plus sine x, this is dx, bracket close. This integration let me do it separately, because this integration we know, this integration let me do it separately here. This is our 0 to pi 1 by 1 plus sine x, this is dx, yes. So here what I will do, this is 0 to pi 1 minus sine x, both numerator and denominator I will multiply it by 1 minus sine x, this is dx. So this is 0 to pi 1 minus sine x by 1 minus sine square x dx, this is a plus b into a minus b. So this is ultimately I will get 0 to pi 1 minus sine x by 1 minus sine square x, this will be cos square x dx. So this is 0 to pi 1 by cos square x minus sine x by cos square x, this is dx. So this is equals to 0 to pi, this will be sec square x minus, this is, you see, I can write it as sine x by cos square x. Yes, this is sine x by cos square x. This is, I can write it as sine x by cos x into cos x. So this will be ultimately 10x. 1 by cos x, it will be sec x. It will be sec x. So I got 10x sec x or sec x 10x. You can say this is sec x 10x. This is our here I am writing dx. Yes, this is I got. So this whole thing I will write it in here. This whole thing I will write it in here because I have already solved it. So this is what I got here. This is what I got, this one. Twice I is equals to pi. Let me write it down. Twice I is equals to pi, bracket start, twice I is equals to pi, bracket start, 0 to pi 1 dx, 0 to pi 1 dx minus 0 to pi 1 dx minus 0 to pi 1 by 1 plus sin x dx, 1 plus sin x, this is our dx. Yes, sin x dx. So this is twice I is equals to pi, twice I is equals to pi. This will be our, that is 1 means integration dx, this will be x, this is pi, this is x, this is 0 to pi minus this one integration, what I have got, 0 to pi, this one I have solved it, I got this one. Yes, sec square x minus sec x 10x dx. So this one I will write sec square x minus sec x 10x, sec x 10x, this is our dx, bracket closed. So this is twice I is equals to pi, this will be our pi minus 0. Yes, this will be our pi minus 0 minus here again I have given a bracket, 0 to pi sec square x dx minus 0 to pi sec x 10x dx. Yes, sec x 10x dx. So here what I will get, twice I is equals to pi, twice I is equals to pi, this is pi minus 0 pi minus bracket integration of sec square x, integration of sec square x is 10x. So this is our 10x, this is our 10x 0 to pi, yes, 10x 0 to pi minus integration of sec x 10x. Yes, integration of sec x 10x, it will be sec x. Yes, integration of sec x 10x, this will be sec x. So sec x 0 to pi, bracket closed, mean bracket close here. So this is twice I is equals to pi minus, this will be our 10 pi, this will be our 10 pi minus 10 0 minus, this will be sec pi minus sec 0. So this is equals to twice I is equals to pi minus 10 pi, 10 pi means this is 0, 10 0 0 minus sec pi means minus 1 minus sec 0 means 1. So this is, I will get twice I is equals to pi minus, this will be 0 only, this is pi minus, this is minus 2. Yes, pi minus, this is minus 2. So this one I will get twice I is equals to pi, this is equals to pi, this will be our pi plus 2. Yes, so twice I is equals to pi square plus 2 pi. So I is equals to pi square plus 2 pi by 2. Now if you this is I is equals to, if you split the denominator, pi square by 2, 2 pi by 2. So this is ultimately we will get I is equals to pi square by 2 plus pi. So this will be the answer, pi square by 2 plus pi. Okay, here I did a small mistake here. You see this is the answer, yes, but I did a small mistake. This bracket I did not give here. There is a bracket here. Okay, so there is a bracket here. This is bracket close, another one bracket there will be. This is minus. There is a bracket here. I missed this bracket, so a little bit answer I got wrong. So here this is bracket, another one bracket there it will be. So this is minus. So here I will have to rub it. So this is equals to twice I is equals to pi minus, this is bracket, okay, pi minus 0 minus 0, it will be 0. So 0 minus, this is our minus 2. Okay, this is our minus 2, minus 1 into minus 1, this will be minus 2. So here let me rub it, this whole. So here this is, I will get twice I is equals to pi bracket pi minus, this is bracket, this will be 0 minus 2, this will be plus 2. Yes, this will be plus 2 bracket close. Okay, this is minus into minus, this will be plus 2. So this is pi minus this is correct. This is pi minus. So this is twice I is equals to pi. This is pi minus 2. So twice I is equals to pi square minus 2 pi. So this is I is equals to pi square minus 2 pi by 2. So here is equals to I is equals to, this will be pi square by 2 minus 2 pi by 2. Yes, minus 2 pi by 2. So this is I is equals to pi square by 2 minus pi. So this will be the answer. This is the next question. This is our integration 1 to 4. This is modulus x minus 1 plus modulus x minus 2 modulus x minus 3. This is our dx. Now this thing, what I will do here, I will split it. Okay, I will split the integration. I will show you in the next page. I will split the integration 1 to 4 modulus x minus 1 dx plus 1 to 4 modulus, this is x minus 2 dx. This will be I is equals to, okay, this will be I is equals to, this is I is equals to dx plus 1 to 4 modulus x minus 3 dx. Okay, so here you see the first integration, modulus x minus 2 x minus 1 integration. This is the graph. Yes, this is the graph. Here in the graph you can see that, here in the graph you can see that only this side, okay, only this side is shaded here, this side is shaded here, and this side it is not shaded. Okay, it is remain blank, only this side is shaded here. Yes, this is integration x minus 2 graph. Here both sides are shaded, here also both sides are shaded. This is the graph for modulus x minus 2, and this is the graph for modulus x minus 3. Yes, this is the graph. Okay, so here what is going on? Here you see both this is the vertex here. Yes, this is the vertex. This is the point where this function x minus 2 will be 0. This is the point. Here both sides are shaded. Here you see at x is equals to 3 in the third graph. Here you see x is equals to 3. At this point the function x minus the function x minus 3 will become 0. So here the vertex is at 3, and in the first graph you see the vertex is at 1, that is at x is equals to 1. At x is equals to 1, this function x minus 1 will be 0. Here at x is equals to 2, this function x minus 2 will become equals to 0, and here at x is equals to 3, this function x minus 3 will be equal to 0. Okay, so these are the graphs. Here why only the right side is shaded? Yes, here only why the right portion of the graph is shaded, the left portion is left blank. Why is that? Now here you see we have already studied that this modulus, yes, modulus, it has both a negative function and a positive function, that is it has a negative value and it has a positive value. Yes, modulus. But in here you see, since the vertex and the lower limit, they're both same. Yes, this function from 1 to 4, this function you see from 1 to 4. Yes, you see here from 1 to 4, this function from 1 to 4, yes, from 1 to 4, this function is always positive. Yes, from this is the vertex, 1, and it is also the lower limit. Yes, this is the vertex 1 and it is also the lower limit, and this is the upper limit. From 1 to 4, x minus 1 will be always positive. Yes, x minus 1 will be always positive here, because you see if I give x minus 1, if I give x value 1, this is, let's say, fx is equals to x minus 1. If I give f value 1, this will be 1 minus 1, 0. Yes, if I give f value 2, this is 1, 2, 3. Yes, 1 is the lower limit, 4 is the upper limit. From 1 to 4, this function x minus 1 is always positive. If I give x value 2, 2 minus 1, this will be 1, positive. F value 3, 3 minus 1, 2, positive. F value 4, 4 minus 1, 3. These are all positive values. Yes, they are all positive. And this is 0. Yes, these are all positive. Okay, so from this lower limit to upper limit, the value of this function is always positive. Okay, so we have already discussed that modulus has two values, one negative and one positive. But from upper limit to lower limit, in these limits from 1 to 4, the value of x minus 1 is always positive. Okay, so therefore this function, for these limits from 1 to 4, this function is always positive here. So therefore I will only take the positive value here. Okay, I will only take the positive value. So therefore this integration I will consider it as I1, this integration I will consider it as I2, and this integral I will consider it as I3. Okay, this is I1, I2, I3. So first integration I will do, I1 is equals to 1 to 4, this is x minus 1 dx. Okay, now as for the limit, for this limit from 1 to 4, the value of x minus 1 is always positive here. Okay, so I will not take the negative value, I will only take the positive value. Okay, So therefore, since I will only take the positive value here, so no need to give modulus here. This is 1 to 4. I can write bracket x minus 1 dx. Okay, so integration will be I1 1 to 4 x dx minus 1 to 4 dx. Yes, so this integration, it will be I1 is equal to x square by 2. Okay, x square by 2. This is your limit 1 to 4 minus this is x limit 1 to 4. Okay, so this is I1 is equals to what I will get here, 4 square minus 2 by 1 square minus 2. Okay, minus this is 4 minus 1. So this is I1 is equals to, this will be 16 by 2 minus 1 by 2. Okay, minus this is 3. So I1 is equals to 8 minus 1 by 2 minus 3. Let's solve it. This is I1 is equals to 8 minus 1 by 2 minus 3. Okay, so this is I1 is equals to, this is 2 16 minus here no need to do this, keep it 16 by 2 minus 1 by 2. Okay, this will be easy for the calculation. Here keep it in this way. So this is I1 is equals to, this is LCM 2, 16 minus 1, yes, minus 3. So this is our I1 is equals to 15 by 2 minus 3, 15 by 2 minus 3. I1 is equals to 2, 15 minus 6. So this is I1 is equals to, this will be 9 by 2. Okay, I1 9 by 2. Next you see I2. I2 is integration 1 to 4 modulus x minus 2 dx. Yes, this is our I2 and this is the graph for I2. Okay, here both sides are shaded. Left hand side also shaded, right hand side also shaded. Why? Because you see this is the function. Let's take fx is equals to x minus 2. Yes, fx is equals to x minus 2. Now from 1, if I give 1 minus 2, I got what? Minus 1. Here we are getting a negative value. If I take f2, then here 2 minus 2, it will be 0. f3, it will be 3 minus 2, it will be 1. And for f4, 4 minus 2, it will be 2. Here you see we get one negative value. Yes, this is the vertex. You see x is equals to 2. At x is equals to 2, yes, at x is equals to 2, this function becomes equals to 0. So the point here 2, it is the vertex, and here left hand side, this is this will be the negative. Yes, this will be the negative, and the right hand side, this will be the positive part. Yes, left hand side it is the negative part and right hand side it is the positive part. Now you see, if I give the function is x minus 2, if I give x value 1, if I give x value 1 here, okay, what I am getting? I am getting minus 1. So at x value 1, I am getting here minus 1. I am getting a negative. I am getting a negative value. Yes, this is 1 here. Okay, so this side it is the positive side, this side it is the negative side. Okay, so since I am getting a negative value here, since I have got a negative value here, so in this integration I will have to take both the values of this function. There will be a negative part and there will be a positive part, so the limit will be split. So what is our vertex here? What is the point at which the function becomes 0? The vertex is 2 here. Yes, the vertex is 2. So the limit will be from 1 to 2, then from 2 to 4. Yes, from 1 to 2, then from 2 to 4. So this will be our 1 to 2 negative value x minus 2 dx, and then from 2 to 4 this will be the positive value. Okay, so here I will have to take both the negative and the positive. This is dx. Okay, this is dx. So this will be minus 1 to 2, this is x minus 2 dx, plus 2 to 4, this is x minus 2, this is our dx. So here this one I will do the integration, then I will do this integration. So this is our integration, x minus 2 dx from 1 to 2. Yes, from 1 to 2, there is a minus sign here. Okay, first of all, this is integration 1 to 2 x dx minus 2 1 to 2 x, this is dx. Okay, so minus, this will be x square by 2, this will be x square by 2, this is 1 to 2 minus 2, this will be x from 1 to 2. Okay, so this is equals to minus, this will be 2 square by 2 minus 1 square by 2, and this is minus 2, this is 2 minus 1. Okay, this is I am getting here. Give a bracket here also. Okay, so this is what I will get, minus, this is I will get 4 by 2 minus 1 by 2. Yes, 4 by 2 minus 1 by 2 minus 2 minus 1, it will be 1, so this is minus 2 minus this I will get how much, 2 minus, let's keep it, this is LCM 2 4 minus 1, and this is minus 2, so this is minus 3 by 2 minus 2, so this is minus LCM, this is 3 minus 4, so this one I will get minus 1 by 2. Yes, minus 1 by 2, this will be ultimately 1 by 2. 1 by 2 I got. Okay, so this part how much I got, this part I got is equals to 1 by 2. Okay, plus now I will have to do this part. This part is same, only the limit is different here. Okay, this part is same, this is 2 to 4 x minus 2, this is dx. So x dx 2 to 4 minus 2 to 4, this is dx. So this will be x square by 2, this is 2 to 4 minus 2, this is x, this is 2 to 4. So this one how much I will get here is equals to this is our 4 square by 2 minus 2 square by 2 minus 2 square by 2 minus 2, this is our 4 minus 2. Yes, this is our 4 minus 2 is equals to 16 by 2 minus 4 by 2 minus 2, this is 2. So this will be 2, 16 minus 4 minus 4, so this will be 12 by 2 minus 4, this will be 6 minus 4, this will be ultimately 2. So this is what I got, 1 by 2 plus 2. So this one 2, 1 plus 4 is equals to 5 by 2. Yes, I2 value how much I got? I2 value I got 5 by 2. Wait, here I1 value I got 9 by 2, and I2 value how much I got? I2 value is equals to I got I2 value 5 by 2. Yes, this is I2 value 5 by 2. Okay, so this is 5 by 2. Next I will I3 is 1 to 4 x minus 3 dx. Yes, this is the function, I3 1 to 4 x minus 3, this is dx. Okay, now here again you see this function fx is equals to x minus 3. If I take f value from 1 to 4, if I take 1 minus 3, I am getting 2 negative value. If I take f value 2 minus 3 minus 1 negative value. If I take f value 3, I will get 3 minus 3 is equal to 0, and if I take f value 4, this will be 4 minus 3, this will be 1, a positive value. So here I am getting negative value also and positive value also. So therefore you can see here the graph is painted at negative side and it is also positive side. Yes, the graph, it is painted in the negative side also, and it is painted in the positive side also. Okay, what is the vertex? The vertex is 3 here. So the limit here also I will have to split the limits. The limit, it will be from 1 to 3, then from 3 to 4. Okay, from 1 to 3, then from 3 to 4. So therefore this integration will be I3 is equals to let me do it in the next page. This is I3 is equals to, it will be from, split the integration, it will be from where? It will be from 1 to 3, then 3 to 4. Yes, 1 to 3, then 3 to 4. So let's split it. 1 to 3, it will be the negative function x minus 3 dx, plus then 3 to 4. Yes, this will be the positive function dx. Okay, so I3 is equals to minus 1 to 3 x minus 3 dx plus 3 to 4 x minus 3, this is our dx. Okay, so I3 is equals to let's do this integration separately. So this is minus 1 to 3, yes, minus 1 to 3 x minus 3, this is dx. So this will be minus bracket start 1 to 3 x dx minus 1 to 3 3 dx. So this will be minus, this is x square by 2, this is 1 to 3 minus 3 x, this is 1 to 3. So this will be minus bracket start, this will be 3 square minus 2 minus 1 square by 2 minus 3 bracket start 3 minus 1. Okay, so this one is equals to minus, this will be 9 by 2 minus 1 by 2 minus 3 into 3 minus 1, this will be 2. So this is minus, okay, this is equals to, this is minus, so this is 2, 9 minus 1 minus 6, so this is minus, this is 8 by 2 minus 6, so this is minus 4 minus 6, so this is minus 2, this is ultimately 2. Yes, and the next part is this. Yes, integration 4 to 3 x minus 3, integration 3 to 4. Yes, integration 3 to 4 x minus 3, this is x minus 3, this is dx. So 3 to 4 x dx minus 3 dx 3 to 4. So this will be x square by 2, this is 3 to 4 minus 3 x, this is 3 to 4. So this is equals to 4 square minus 2 minus 3 square minus 2. Okay, this is, and this is minus 3 4 minus 3. So this will be 16 by 2 minus 9 by 2 minus 3. Okay, so this is 2, 16 minus 9 minus 3. So 16 minus 9, this will be, so this will be 7 by 2 minus 3. Okay, so here if I take the LCM, this is 2, this will be our 7 minus 6, so this will be 1 by 2. Okay, so here what I have got, here I got, this is 2 plus, this is how much I got 1 by 2, 1 by 2. So here I3 will be 2 plus 1 by 2, this is I3 will be 2 plus 1 by 2, so this is 2, 4 plus 1, so this is 5 by 2. Okay, this is I3, this is I3 I got 5 by 2. So here this one I1, how much I got, I1 I got 9 by 2, this is 9 by 2. Yes, I2 how much I got, I2 how much I got, I2 I got I2 I got 5 by 2. Yes, I2 I got 5 by 2, this is 5 by 2. And I3 how much I got, I3 I got 5 by 2. Yes, I3 I got how much, 5 by 2, I3 5 by 2. Okay, so I, these are all plus, so I is equals to this, all I will have to add here. Okay, so I is equals to I1 plus I2 plus I3. So here I is equals to I1 9 by 2, 5 by 2, 5 by 2. Yes, 9 by 2 plus 5 by 2 plus 5 by 2. This is our 9 by 2 plus 5 by 2 plus 5 by 2. Okay, so there I will add them. So this is I is equals to, this is 2 LCM, 9 plus 5 plus 5. So I is equals to, this will be 19 by 2. 19 by 2, 2 nines are 18, 1.0, 2 fives are 10, this is 0. So therefore I is equals to 9.5. This is the answer.